Welcome back. I've been away for a while, and the reason for that is simply because I had a lot to do in the house. And since it's summer and the weather allows me to do quite a bit of work without having to worry too much about the weather, well, I rather selfishly maybe started to work on the house instead of my project for the moment, which is the Sony 5303E. But tonight I don't feel too tired, and well, actually I sort of felt like working a little on electronics, and by the same token give you an update on where I stand. Now, you remember in the last episode that I told you that I was going to replace all the electrolytics on this board. The board which essentially drives the CRT in the TV. So it has the vertical sweep, the horizontal sweep, you name it. Even a part of the oscillator for the high voltage. Well, this is all included in this board. Okay, so just to recap quickly, I'm going to replace all the electrolytics on the board, as well as this paper cap here. And I'm going to use rather unglamorous parts, something like this. Okay, just a normal type of electrolytic, nothing special. Hang on, I'm going to give you a little bit more light. So I'm going to use a rather unglamorous electrolytic and a normal plastic type of actual capacitor to replace this one. Now this one is rated at 400 volts. This one is rated at 630 volts. So well, most of my capacitors are rated for 630 volts, or well, a few perhaps only 400 volts, but most are rated at 630 volts or higher. Now the reason why is quite simple, because then I don't have to worry as much that I won't be able to replace any defectuous part in one of my projects. I do have low voltage electrolytics like this one, but let's say in the main I have only capacitors rated for 400 volts or over, just to be on the safe side. So that's what I'm going to do now. I'm going to replace all the electrolytics on this board and this one paper cap here, and then I'm going to measure all the resistances just to make sure that they work properly and that they are still within specification. And you can tell for yourself, most resistors on here on this board are little dog bone resistors like this one. The reason why I replace capacitors is well, understandably, because most of the time old capacitors are unreliable, and this is the original capacitor that was on the circuit, which I replaced by this one here, which is 47 nanofarad, 630 volts. That's what it's rated at. This one is a 50 nanofarad, 400 volts. Now, I guess I could have found somewhere a 50 nanofarad capacitor, but well, I don't want to go through the expense of buying a 50 nano, especially for this circuitry. Well, it's not a particularly valuable TV as such. So I'm not too concerned with authenticity, but more with reliability. Now, the reason why, as I was saying, I replaced those capacitors is simple. I hooked this one up to my capacitance meter, and well, you can tell for yourselves, the meter says it's 64.4 nanofarads, while it should be 50 nanofarads. So if we take, even if we take a tolerance of 20%, it's still wide over. So that's the reason why those paper caps, whenever I encounter them, I do replace them. And then there's the electrolytic. Now, the original electrolytic, which is of the brand Elna, was rated at 100 microfarad, 8 volts. Now, I replaced it with this one here, which is an unknown brand, but is rated at 100 microfarads, 50 volts. And you can tell for yourselves that if I put an 8 volt 100 microfarad next to a newer model, well, you can tell that it has reduced in size. And it is capable of working at a very much higher voltage. Now, I replaced this one, and I'll show you why. So here we go, like this. And by the way, you see a small arrow on this electrolytic. Well, the arrow depicts the cathode of the capacitor. Okay, so now I connect the anode. If I can manage with one hand, which is not too simple. Yep, there we go. Okay, so now let's see what the meter tells me. Well, there you go. It should be a 100 microfarad capacitor, and you can tell for yourselves it is closer to, well, I would say 41 microfarad. So it is quite bad. Okay, so that's why I replaced those capacitors without even bothering to measure them first, because I know they will be bad. Now, there is one more problem. If, or rather while I was replacing these capacitors that I showed you, I found a problem right there. I don't know if you can see it, but you see this resistor here. This resistor should be a 1K resistor, and you can tell for yourselves if you compare this one with, say, this one, yeah, that this one looks pretty burned. And in fact, I'm quite certain it is burned. Now, the leads are so short, that I can't measure it on its own. So I have to take it out. And anyway, you know, I'm not even going to bother to measure it in circuit, because judging by its state, it's probably burned. I mean, completely burned through, and you can tell that for yourselves. Now, this resistor, which is a 1K resistor, is in series with this diode. Now, I think, if I'm not mistaken, this is a germanium diode and not a silicon diode. Now, the type of this diode is a 1S125. Now, I looked up the specifications of this diode, and it seems to be a diode which is rather close to, in specifications I mean, to a 1N4005. Now, I don't have a 1N4005, but I do have a lot of 1N4007s. Now, this diode, which you see here, is rated for 600 volts peak reverse voltage, and for 600 milliamp forward current, and 100 excuse me, let me think, peak reverse voltage 500 volts and forward current 600 milliamps. Now, a 1N4007 is rated for 1000 volts peak reverse voltage and can handle up to 1 amp, not 600 milliamps. Also, this diode can only take about 100 degrees Celsius while working, while a 1N4007 can handle up to 150 degrees Celsius. So I think I'm not going to try to find exactly the same diode on the market, because it will probably be quite expensive, and I'm not going to order just one for the sake of authenticity. The reason why actually I'm saying that I'm going to replace this diode is because this resistor here is in series with this diode. Now, the fact that this resistor burned through makes me quite suspicious of this diode as well, and I'm not going to take any risks, because this is part of the circuitry that generates 300 volts DC, which goes to the grid of the CRT, at least to the, if I'm not mistaken, to the focus grid of the CRT. Let's have a look on the schematic. Okay, so first of all, I had to locate the part. So I looked on the diagram, which I found on my SAMS service manual, and this is the diode I mentioned. Yeah, this diode is actually the part number on the diagram, on the schematic, is X25. So this is the one. And the resistor which is burned through is actually this one. Yeah, and when we follow this arrow, it goes to R114. Now, notice that the resistor on the SAMs is in upright position, while the one I'm confronted with is in horizontal position. Yeah. Okay, so that doesn't really mean anything. It's just that they mounted it differently. Now, the thing is this. If we look at the schematic, okay, let me show you on the schematic. If you look on the schematic, you'll see here, let me do a close-up. You see here that the R114 is a 1000 ohms or a 1 kilo ohm resistor, and it's in series with the X25 diode, which is the one I just showed you. And this diode is a 1S125. Now, like I said, it's rather equivalent, let's say, to a 1N4005, but I will probably replace it by a 1N4007. Now, if you look at this diode and you go back and back and back, you come to the high voltage coil inside the TV, which is used to generate the high voltages needed for the CRT. And in fact, it's connected to pin 3 of the high voltage coil, which you see here. Now, if you go in the other direction, you see the diode, you see the resistor which has burned, and then you see the capacitor which I just replaced, yeah, which is that 50 nanofarad capacitor, which is this one here, yeah. So this one, yeah, is actually, if I'm not mistaken, is this one. Now, if you look carefully, you'll see that this capacitor, which is this one here, is connected directly to ground. So at the output of the 1000 ohms you see here, there is this capacitor which is connected to ground. Now, what I think happened is that this capacitor shorted. So inside this capacitor there's probably a short somewhere, which means that there was quite a lot of current starting to flow through this resistor and, of course, through this diode, which made this resistor burn. The resistor might still be conducting a bit, I don't know yet, but quite probably due to overheating, its resistance will have risen to quite a higher value, which in a sense is a sort of a mixed blessing, since the higher resistance will have automatically limited the current that went through it and thereby protecting the high voltage coil. At least that's what I hope it did. So well, the thing I'll need to do now is to take out these two components, the diode and the resistor, and replace them, and then see whether the coil here, when I measure the value, which should be 3 ohms between pin 1 and 3, well, whether the coil is open or still closed. So that's what I'm going to do next. Okay, this is the offending part, or one of the offending parts that I unmounted. As you can tell for yourselves, this diode looks pretty fried as well. You see the plastic tubing on its end? Well, it's really black and melted, and well, it doesn't look pretty. Also, when you look at the what I think is a cathode of the diode, then you see there's stuff oozing out, a little bit of brown stuff oozing out of its cap. So my guess is this diode did indeed heat up quite a bit. Now, funnily enough, when I measure it with the positive lead to the cathode, negative lead to the anode, it doesn't conduct, as it shouldn't. Let me see. It doesn't conduct at all. So, or well, 16 mega ohms. Well, that's pretty high. If I reverse it, then it should conduct. And it doesn't. It doesn't conduct at all. Well, the meter is going in all directions. You know, it's pretty unreliable. Now it says 124 kilo ohms. Well, I would tend to say that is a bit too low a value for this for this diode. So, well, you know, normally a diode, when it's in the conducting position, or when it's connected in the conducting mode, should read a much higher value, or somewhere around 250 or 300k. This is 127k. It might still be good, but really I don't really trust it. The resistor, which I took out, as you can tell for yourselves, is looks pretty fried, and in my opinion it is dead. So let's see. I'm on the 200k setting, and remember, this should be a 1k resistor. Nothing. Okay, nothing, absolutely nothing. So yeah, it's like I said, the resistor is dead. And now let's see, I took a metal film 1k resistor to replace the dead one. So let's just check if this one works. And it does, and it gives exactly 1k. That's good. Okay, now the diode. This will be the replacement diode I'm going to use, which is a 1N4007. Let's see how this one measures. So if I connect cathode to the negative and anode to the positive, 123k. Okay. So maybe I was wrong. Maybe 123k is normal. So let's reverse. That shouldn't. And indeed, it doesn't conduct at all. So only perhaps in the very highest measurement position it might conduct, but in the 200K it doesn't conduct in the reverse. So my conclusion is that the original diode probably is still good, but it's certainly overheated, or well, it's certainly heated to quite a high temperature because it oozes from all sides, and the plastic around it melted. So I'm not going to trust this diode. I'm going to replace it with the 1N4007, and I'm going to replace the resistor with a metal oxide 1K resistor. By the way, if I'm not mistaken, this is a 1/4 watt, which I think this one is as well, this little dog bowl. Okay, so here we go. Before I put the new parts into place, I want to draw your attention to the PCB where the resistor was mounted between this hole and that one. And I think you can see right here a burn mark. So the PCB right here must have been pretty hot for a while to bubble up like this. So because this is phenolic plastic, and that's supposed to be able to withstand quite a high temperature. It certainly withstands heat from a soldering iron, so I think for it to bubble up like this, it must have been really hot. So you remember last time I put a tag along this edge with the color of the wires that were connected to these pins. Now, after cleaning off the PCB a little bit, look what I found. If you look carefully, you'll see that right next to the pins, but it's kind of hard to see, it's faint, you'll see letters. Yeah, next to this pin, for example, the upper pin, you see the letter R, but it's kind of hard to see. Okay, the letter R. And then underneath you'll see the letters BK, BU, and then W. So that's kind of faint here. W. And then next to the lower one you see a Y. Now this stands for red, black, blue, white, and yellow. Now I hadn't noticed it, as I said, because the print ball was quite grimy, and well, there was also a lot of dust. It was only when I started to clean that I noticed it. So actually Sony did go a little bit further to make the life of a technician a little bit easier by marking the colors of the wiring that should be connected to these pins, which is a nice detail.